Okay, so we have learned two different types of factoring already, and today we're going to talk about putting them both together. But before we do that, let's go ahead and just review. So the very first type of factoring that we learned was factoring by pulling out a GCF. And so if you look at this problem right here, there is a GCF. What number does 36xy to the third and 20y to the fifth have in common? Well, 36 and 20, they both have 4 in common. And then they both have y to the third in common. They have at least 3 y's. We wouldn't pull out an x because the 20y to the fifth doesn't have an x on it. And then you divide out the 4y to the third, which is going to leave me with 9x plus 5y squared. And so that's just a quick review of factoring by pulling out a GCF. And then we learned that sometimes there's not a GCF. So in this problem right here, there's not a GCF, but it is a trinomial. And since it's a trinomial, we can factor it into binomials. And so the way to do that is start first by doing your 2 sets of parentheses. And then look at 6x squared, the very first term. And so I'm going to break up 6x squared. I could do 6x, or I can do 6x and 1x, or I can do 3x and 2x. And I'm going to go ahead and try 3x and 2x. And then I can look at the 4. And so you got to remember that when you're breaking up this 4, that goes here and here. So I could try 2 and 2. And so I'm going to kind of just think through this in my head. If I put a 2 here, it's going to get multiplied by this 2. So that's going to give me 4x. If I put a 2 here, it's going to get multiplied by the 3x. So that's going to give me 6x. So I need to think to myself, is 6x and 4x going to give me 11x? It's not. It's only going to give me 10x. And so I should probably pick something else for 4, which is 4 and 1. So let's think through this. If I put the 4 right here, that would give me 8x. And if I put the 1 here, that would give me 3x. And is 3x and 8x going to give me 11x? It absolutely is. So that means that I'm going to put 4 here and 1 here. And I know that both the signs are positive because the last term is positive and the middle term is positive. So if the whole problem is all plus signs, it's going to be plus plus. And so just to double check, my inners are 8x, my outers are 3x. If I put them together, that's 11x. Now, before we actually start to put the two together, I want you to go ahead, let's draw a line down the middle of your paper here. So I'm going to draw a line right here. And on the left-hand side, I want you to go ahead and factor this guy into binomials. So start off by starting with your 2 sets of parentheses and go ahead and break up the first term and the last term and see if you can get negative 49 in the middle. And then do the same thing for the 6x squared plus 36 plus 30. Go ahead and do that and see what you come up with. So stop the video and do that. Alright, so now if you did these problems and then compared with a neighbor, it's very possible that your neighbor has a correct answer with a different answer than you. And so if you look, this first problem right here, it actually has 2 different ways that it can be factored. And the second problem actually has 4 different ways that it can be factored. Now that can get very confusing when there's different ways to do things, so we want to avoid that completely. Pretty much none of these are what we would say are factored completely. The reason is because we have a GCF. If you look at the 14x minus 7, there's a 7. I could pull a 7 out of that. And same here, this 7x minus 21, I could pull a 7 out of that. And what happens when I do that, let's take the first one for example, whatever answer you ended up getting, go ahead and you're going to adjust it. So this one has a GCF of 7 in it. If I pull the 7 out, then I'm going to be left with 2x minus 1 inside there, and then the other x minus 3. And the second one, if you got this answer, if I pull the 7 out of this, I would end up with 7 on the outside, x minus 3, and then 2x minus 1. And if you look, aren't these the same answer? So what we would do to avoid ever having to do this is we would start this problem by pulling out the GCF first. And if you pull out the GCF first, then the problem is actually easier to factor into binomials. So let's take a look at this problem again. If we notice at the very beginning that the GCF is 7, then we start the problem by pulling out the GCF. And you have to write the GCF. It is now a factor of this problem. So when I pull out the 7, I'm going to be left with 2x squared minus 7x plus 3. And then you have to bring that 7 down, but now I'm going to look at just this trinomial, and I'm going to try to factor that trinomial. And so then I break up 2x squared. There's only one way now to break up 2x squared. That's going to be 2x and x. And then you look at the 3, and you try to break up the 3. There's only one way to break up 3 and 1. And so think ahead. If I put the 3 in the first set of parentheses, I'm going to have 3x times 2, or plus 2, which doesn't give me 7. So if I put the 3 over in the other set of parentheses, and the 1 here, and they both have to be negative. So the reason they're both negative is because you need a positive at the end, but a negative in the middle. And so now, if you check your inners, you have negative 1x minus 6x. And isn't negative 1 minus 6, 7? And then if I were to distribute that 7 back in, don't I get this? And then notice, this is also the same as that, and the same as that. Okay? Now the next one. If you look at these, all 4 of these have a GCF in them. Let's go back over here and let's just factor it again to see what the correct answer is by starting the problem by pulling out a GCF. And you're going to find if you pull out the GCF, the problem's going to be easier. So there's a 6. They all have a 6 in common. So if I pull out the 6, I'm going to be left with x squared plus 6x plus 5. And then I go to split that up. So I put the 6 and then go to split up that trinomial x squared plus 6x plus 5 now. The x squared breaks up into x, and the 5 can only break up into 5 and 1, and they're both addition signs because everything is positive. And so now if you're checking your answer, what you end up doing is you multiply these two things together. So if you were to do FOIL and go through and do FOIL, you would get this. But then that 6 out here is really important because then if you distribute that 6 in, then that brings you back to this. Okay? The correct answer would be this. All right? So now, if I look at this right here, if you look at this problem, so we're going back over to the left, this has a GCF of 3 in it. If I pull that 3 out, I'm going to be left with x plus 1. And this has a 2 in it. If I pull that 2 out, I'm going to be left with x plus 5. And if you think about this, all being multiplied together, isn't 3 times 2, 6? And then you have that factor of x plus 1 and x plus 5, and that's what you would get right there. In the next one, you would pull out a 2, and you would pull out the 2, and you'd get that x plus 1. And then you pull out the 3, and you'd get that x plus 5. And if you put the 3 times 2 together, you're going to get that 6, and you're still left with the x plus 1 and the x plus 5. And so it's true for these two. If I pull the 6 out here, I'm going to get an x plus 1. And then the x plus 5 doesn't have a GCF, so you just leave the x plus 5. Okay? This next one has a 6. Whoops. And so I'd get 6x plus 5. And then the x plus 1 doesn't have a GCF, so I have x plus 1. So if you look, all of these are the same answer. So conclusion is that you can pull the GCF out at the beginning or you can pull it out at the end. However, it's always going to be easier if you pull it out at the beginning first. So now, whenever we are doing a problem that says factor, we need to train our brains to ask ourselves first. You get a problem, says factor, the first question you have to ask yourself is there a GCF? So looking at this, is there a GCF? Why, yes, there is a GCF. What is the GCF in this problem? Well, they all have at least a 4 in common, and look at the variables as well. They all have a y squared. So if something does have a GCF, we pull the GCF out first, and we have to write the GCF down. So I've got 4y squared, and then I'm going to divide out that GCF, which is going to leave me with x squared minus 5x plus 6. And so once I've done that, I have that trinomial. So now I'm going to now factor it into binomials. But don't forget your GCF. Your GCF is a factor. You can't get rid of it because it's still a factor. So I'm going to have that 4y squared there. And then I'm going to break up the x squared minus 5x plus 6. The only way to break up x squared is x and x. So that makes the problem so much easier. And there's a couple ways to break up 6. I can break 6 into 6 and 1 and 3 and 2. But I'm trying to get negative 5 in the middle. Keep in mind, just a reminder, when the last term is positive, that means the signs of my factors have to be the same. And since my signs have to be the same and the middle term is negative, my signs have to be negative, negative. Because a negative times a negative gives you a positive, but a negative plus a negative gives you a negative. So like the middle term you're adding, you add your like terms together. So a negative and a negative together still gives you a negative, but when you're multiplying to get the last term, that's where you get that positive. So the way to break up the 6 is the 3 times 2, right? Because 3 times 2 is 6, but now my inners, this gives me negative 3x, negative 2x, which gives me negative 5x. And then if I were checking, I would take this, I would distribute it in, and that will bring us back to that. Okay? Let's do the next one together. So the next one, is there a GCF? Yes, in this case there is a GCF. If you look, what is it that they have in common? Well, they all have a 6 in common, and they all have an x on them. So 6x is my GCF. So I'm going to pull out the 6x, and then I'm going to be left with 10x squared minus x, which is really 1x, minus 3. You have this trinomial now. You're now going to factor that into binomials. But don't forget the 6x. Lots of people pull out their GCF and they forget to write it down. That's part of the answer. And so now, let's see if I can break up my 10x squared. So I can do 10x times x, or I can try 5x times 2x. I'm going to go ahead and try 5x times 2x. And then you're going to look at that negative 3. Now remember, when it's a negative 3, at the end, that means your signs inside your factors have to be different. And then our outers and our inners have to give us negative 1. So keep in mind when you're figuring that out, where you're deciding where to put the 3, you have to figure out how you're going to get negative 1 in the middle. So let's think, if I put the 3 right here, then it's being multiplied by 2x, which is going to give me 6x. And if I put the 1 right here, it's going to get multiplied by the 5. And isn't 6x negative 6x and positive 5x? Doesn't that give me negative 1x? It does. So I am going to put negative 3 right here and positive 1 right here. And again, how does this work? If you did FOIL with all of this times this times this times this, you did FOIL with all of this, that would bring you to this trinomial. And then when you distribute that 6x in, that's going to bring you back to the original answer. So this answer, both of these answers, they have 3 factors in the answer. All right? Stop the video and try the next one on your own. Okay, hopefully you got it right. You should have ended up with a 2, a 5x, a 5x plus 1, and a 2x plus 5. So this is your correct answer minus my little scratch mark that I put in there. Okay, so now let's go ahead and try a few more together. I'm going to split the video up just a little bit. So what I want you to do right now is we're going to just do problems 4, 5, and 6 to start with, and then we're going to move on to the next section, okay? And I'm going to give you a chance to do it, try them yourself for just a moment. So if you look, the directions say factor, and so now when you see that factor, your brain should now try to be trained to say, pull out the GCF if there is one, and then factor into binomials if I can, okay? All of these problems can get factored into binomials. Some of them have GCFs and some of them do not. Another reminder, remember, if the first term starts with a negative, you have to pull out a negative GCF. So if you look, this one right here starts with a negative. Remember when I said we would never factor the first term into any kind of negative? The reason is because we want to make the problem easier by making that first term always positive. That way we are avoiding several different ways to to factor a polynomial. So we all end up with the same answer. So you're never, ever, ever going to break up that first term into a negative because you're always going to pull out a negative GCF. So go ahead, stop the video. I want you to only do problems 4, 5, and 6 right now, and then come back and see if you're correct. All right, so if you take a look at the first one, I just want to do a quick reminder about signs. Since this last one is positive 108, the signs have to be the same, and my signs had to be negative because it goes negative, negative. I'm just now noticing that I made a mistake in number 5. These should be subtraction signs because the signs have to be the same, but since the middle term's negative, it should be subtraction. So these guys right here are subtraction signs. I made a mistake. So minus 12 and minus 3. All right, and then in the next one, the signs had to be different of my factors because that's the only way to get negative 15. And then another way to think about it is that since I want negative 7x in the middle, that means the number where I get the biggest multiple is going to have the negative sign, right? So since this outside term gives me negative 10, this inside term gives me 3, since 10 is bigger than 3, that's going to be negative on the 10 because we want to get 7 to be negative, okay? So be real careful with the signs there. Sorry about the mistake. So I know it's weird. I want you to skip these next 6 problems right now, and let's move on to the next. So far, all of the polynomials that we've factored into binomials have been trinomials. Remember, 3 terms means trinomials. However, let's remember special products. When I multiply this special product right here, 5x minus 4 times 5x plus 4, that's a difference of squares, right? When I factor that, doesn't that give me 25x squared minus 16, right? Because this is an example where my inners and my outers are 0 because they canceled out, right? And so this means that the factors of this polynomial, 25x squared, whoopsie, minus 16 are 5x minus 4 and 5x plus 4. So these are the factors, the 2 factors of 25x squared minus 16. All right? So now, this is super important. The only time that you can get a binomial instead of a trinomial from multiplying 2 binomials together is when it's our third special product, where the factors are the same and you have one of each sign. So therefore, if you have a binomial that is a difference of squares, you can factor it into binomials. That is the only time you can factor something with only 2 terms, is if it's a difference of squares. So now let's go back and look. All of these are differences of squares. Why are they all difference of squares? Because the middle term cancels out, and then here's another clue. They start and they end with perfect squares. If they don't start and end with perfect squares, then it doesn't work, okay? So if you look, the only way to break something up into a difference of squares is if the factors are exactly the same, have the same numbers in them, except one's addition and one's subtraction. So if I'm gonna go factor 4x squared minus 49, the only way I can do it is if I can break 4x into 2x and 2x, and 49 into positive 7 and negative 7. Because if you think about that, my inners and my outers are both 14, but one's negative and one's positive. Over here, that's going to factor into k plus 8 times k minus 8, okay? Now see, 121 r to the 4th. Well, we haven't seen r to the 4th, but that's okay. We can break up r to the 4th and r to the 2nd, right? So this is going to break into 11r to the 2nd plus 20 times 11r to the 2nd minus 20. If you think you have it, stop the video and try the next 4. If you don't have it, go ahead and stick with me, right? So look, this first one, 225p to the 6th, isn't that a perfect square? It is. We can break 225 into 15 times 15. So this is going to break into 15p to the 3rd. Well, 289 is 17 times 17 gives us 289. See, again, reasons we need to know perfect squares. So 15p to the 3rd minus 17 and 15p to the 3rd plus 17 is going to work out. All right? And so the reason you have to break up p to the 6th and p to the 3rd and p to the 3rd is because when you go to check your outers, right, your outers and your inners, they have to both be like terms. So they both have to have p to the 3rd on them, and these are going to cancel out, all right? The next one is going to be y plus 1 times y minus 1. The next one, 9m to the 2nd plus 25 times another 9m to the 2nd minus 25. The next one, x to the 6th plus 1 times x to the 6th minus 1. And if you don't believe me, go ahead and do FOIL on all of them and you should see that it works. Now, this will only work if it's a difference of squares. And all difference of squares has to be a perfect square minus a perfect square. If it's a perfect square plus a perfect square, it doesn't work. Because remember, if your last term is positive, the signs have to be the same. And if your signs are the same, you will always get a third term in the middle, okay? So in this case, it's only a perfect square minus a perfect square. So do me a favor, turn off the video and, well, listen to my directions first. So circle the ones that you can factor in this way, then factor in them, and if you can't factor it, you gotta tell me why. So turn off the video, circle the ones that can be factored into a difference of squares, and then factor those, and then tell me why you can't on the others. Okay, so the only ones that you can actually factor into a difference of squares are j, k, and n, and go ahead and look to see how I did that, right? And if you don't believe me, check your inners and your outers, and you will find that any of these other ones, you will not cancel out your middle term. So let's talk about why this one. This one is no, because it's an addition sign there, okay? This one is no because 20 is not a perfect square. You can't break 20 up into two of the same exact number, all right? Letter L is no because it's addition. M is no because x to the 3rd is not a perfect square. And O is no because 6 is not a perfect square. All right, let's move on to the next little section. So now, if you're going to put it all together, let's look at both types of factoring. So if you look at all 5 of these problems right now, you might automatically go, well, none of these can be factored because none of them are a perfect square minus a perfect square. However, they all have a GCF. So let's go through and let's pull out the GCF and then ask ourselves, can I take it a step further? So if you look at the first one, I can pull out a 2. So if I pull out a 2, I'm going to be left with x squared minus, well, 98 divided by 2 is 49. Now, is x squared minus 49 something that can be factored? Yes, because x squared is a perfect square and so is 49. So the 2 is just part of your answer, and that can get further broken up into x plus 7 times x minus 7. All right? Now Q is a little bit different. I'm going to put that answer down here. Because the first term is negative, I have to pull out a negative GCF of negative 2x. Or negative 2, not 2x, just negative 2. When I divide everything by negative 2, I'm left with x squared plus 49. And in this one, I'm finished. I can't take that further because if I try to break up 49, the signs have to be the same. And if the signs are the same, when you check your inners and your outers, the middle term will not cancel out. Okay? Stop the video. Try the next 3 right now. Now, hopefully you didn't let me trick you on these next 3 because all we can do on the next 3 is pull out GCFs. So in R, if I pull out negative 2g, you're left with 9g plus 4. And first of all, g is not a perfect square because it's not g squared. And then because that's addition, I can't break it up anyway. So this one is finished. And then S, don't let that mess you up. When I pull out the 90, you are left with 1 minus 4h. And your brain might go, but both of those are perfect squares. 1 and 4 is, but h is not. It has to be h squared, okay? T, all I could do was pull out 5x squared, and I'm left with x squared minus 14. 14 is not a perfect square, so that cannot be factored, okay? So you can only factor binomials if it's a perfect square minus a perfect square, all right? Now, there are some problems left at the top that you haven't finished. 7 through 12, up above. I want you to stop the video and see if you can get through these problems without my help and then turn back into the video. If somebody in your group is finished and at this point, go ahead and work together on them if you want to. Good luck. And here are the answers. Please, 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 if you are struggling, please find someone to help you, okay? Quick thing I want to point out on question number 8 and question number 9, notice that when I factored this trinomial here, I factored it into the square of a difference. Since both of those are the same, I could write my answer this way. I could write it as negative 6xy times 2x minus 1 squared. You're not going to get it wrong if you don't write it that way. I just want you to know that it can be written that way, and you might see it written that way sometimes. And same with this one. That is the square of a sum, and so it ended up with this right here, okay? Another quick reminder, don't forget, I'm pulling out -1 when there's not a GCF, but the first term is negative. And then number 11 didn't have a GCF, and neither did number 7. So you just factor it normally, okay? Good luck. Let me know if you need help.